We can also measure the flow through the actual NPU, and that's useful for finding as to when the NPU is starting to block up. So you can set a lower pressure limit in which will raise an alarm. You'll get a message, text message, email, telephone call, whatever you need, and also the siren will sound and it'll display in red. To do that, we need one of these flow meters. These are you have a pitot tube on the front, and that can measure the flow through your NPU. I'm going to show how to set one of these up now. Pretty simple, just like the pressure sensor. You put it on the front, the pressure monitor will automatically recognize it. No need to set it up in that sense. The critical thing with this though is to get it roughly calibrated. Obviously these machines, they have a non-return valve in them, which is just a flap there. Just a very quick guide to these motors, these fans. One side they have the actual electric motor, and on the other side is the air inlet. So on this machine, the motor, you can see if you look through the hole, there's a motor on that side, and on the other side there is a clear air. There is nothing there. You really want to point the pitot tube, which is that on the side with the clear air. It's not hugely critical, like I say, because it'll be roughly about the same. You just have to recalibrate it in the software no matter where you put it. One thing is critical though, it has to, when the fan is running, the flap will open like that. You need the pitot tube to be underneath the flap. Obviously, it will read nothing. If you have the pitot tube, which is effectively just measuring the airflow, if you have it up there, it's not going to work. You need to have it below the flap so it can actually read the airflow. So to fit it, with most fans, it'll just slide on the front like this. To get a very rough calibration, basically you would just rotate it to get a reading about what your machine should say. I think that's roughly where it should be. If you want to do a really permanent installation, really good job, you'd also put a screw in the top and bottom to keep it in the right place, but you can't just leave it hanging off. Okay, so the machine's reading 1866 and our flow meter's reading 2042, which is slightly different. So we can scale that to be the same. So that's about 1850 at the moment, and this reads about 2050. So I'm going to go to the calculator. I'm going to do 1850 divided by 2050. So that's the reading on the machine divided by the reading on the flow sensor. And that gives us a scale of about 0.90. So then we go into our settings again, just click on the settings icon, and change that to 0.90. Submit. Okay, and the next time we get a reading from it, it should be roughly the same as the machine. Yeah, there we go, 1835, 1852. Because it constantly varies, it'll never be precisely the same, but you can calibrate it to be almost exactly the same throughout the whole range. What we're particularly interested in though is the upper and lower limits. So it is possible that the filter could totally rupture and then the flow would actually increase through the unit. So we do actually have an upper limit. How practical that is, I don't know. It's really the lower limits that we're particularly interested in, because that will tell us when the filter is blocked. The ED 6307 guidelines recommends for 2000 around 1700 meters cubed an hour, so that's what we set it to there. So basically what that means is if the flow drops to 1700 or below 1700 meters cubed per hour, then we'll get a printout. We could get an SMS call, telephone call, email, and it'll sound the siren within the unit.